is two functions that are defined by f of x and g of x equals x squared plus x plus 7. Find the coordinates of the points where the two curves y equals f of x and y equals g of x meets. Well, you notice that these two red points I've dotted, the y values are the same for both curves at that point. So all you do is say y equals y, then you say f of x equals g of x, and then you write down your two formulas, 2x squared minus 3x plus 2 equals x squared plus x plus 7. Bring it over one side. We're going to get x squared, that's 1x, comes out the other side as minus 1x, so it's going to be minus 4x. Bring the 7 out the other side, comes minus 7, you have minus 5 equals 0. You're going to have x minus 5, x plus 1 equals 0, x equals minus 1, x equals 5. Now, you're looking for 2 points, so you need x, y, followed by an x and a y. So to do this, one of them is 5, the other one's minus 1. You can choose either equation, they both give you the same answer. You see the way these points are on both lines, so you can use either equation because when you put in the x value, they have to give you the same y value because they're both at the same point. Okay, so look, go with g of x purely because it's easier. G of x equals something squared plus something plus 7. See why I just left it blank? So all I have to do is put in g of 5, isn't it? So 5 squared plus 5 plus 7 is 37. And then g of minus 1 is going to be, what am I saying again? Minus 1 squared plus minus 1 plus 7. Yeah. Now, what I'm going to do next is, all that's done, you happy with that? So that's minus 1, 7 and 5, 37. That's the only piece of information we got from that first part anyway. So what I'm going to do is just going to rub out all this. And what I'm going to do next is I'm going to bring the second question up towards it, just because it'll make it easy. Now, what I'll do next is do this here. We want to find the area of the region. Oh no, shouldn't have done that. So area of the region close between the two curves, okay? So it'll be this question here. Now, what I want to show you here is, there we go, 1 second. There we go, just that there. Okay, now find the area enclosed between two curves. Now, if I was to do F only, G only, see G, yeah? G would be this red region here. Is everybody happy with that? G is that region there, okay? Now what we're looking for is we're looking for this blue region in here. That's what we're aiming to get, okay? So in order to get that, what I'm going to do is I'm going to get the black region. The black region is the integral of f of x. So it's the integral of f of x dx, oh sorry, g of x dx, excuse me, it's underneath g, not x. So it's the integral of g of x dx. And what are the limits? It starts at minus 1 and ends at 5. Now, next thing I'm going to do is colour in a green region. Can anybody tell me what the green region represents? The region underneath f of x. So you have your region of 5 to minus 1, f of x dx. So you have one minus the other. Okay? And what we're going to do then is we just obviously rewrite this so it has the two equations. So it's 5 minus 1, what's g of x there? X squared plus x plus 7 dx. And then followed by, now remember what do these two lines mean? Absolute values. It means if you got minus 36, the area is 36. The sign doesn't matter. Okay? So what we can do is we can probably just do each one individually would be the best way to sort it out, to be honest. Let's just do one at a time. Okay? So we do one at a time. What we're going to get is, we'll start off with the black region. Add on a power, x3 divided by the new power. Add on a power, divide by the new power. And then add on an x. And then that goes from 5 to minus 1. You're going to get a 5 cubed over 3 plus 5 squared over 2 plus 7 times 5, and then it's going to be minus brackets minus 1 cubed over 3 plus minus 1 squared over 2 plus 7 times minus 1. Going to put all of that into the calculator, and there's no need, it's equal to 60. Okay? Now, that's just this one here, Simon.
Yeah, I understand. I can't get you going.
Okay, and next one's green, okay? So, green is, we're not going to take the minus into consideration just yet. So it's the integral of 5 to minus 1. What's the formula? 2x squared after 2x squared? Minus 3x plus 2 dx. Integrate. So lads, what happens when we integrate the 2x squared? X cubed. The 2 was there to begin with, and you got to divide by your new power. Next one, your new power is going to be x squared. The 3 was there beforehand, so you got to divide by the 2. And then for this one, you just add on an x, and then you go from 5 to minus 1. You write this out longhand, you're going to go 2 times 5 cubed over 3 minus 3 times 5 squared over 2 plus 2 times 5. Take away and put this in brackets. You're going to go 2 times minus 1 cubed over 3 minus 3 times minus 1 squared over 2 plus 2 times minus 1. Now, when you put that into your calculator, the full thing is going to be a negative 96. Oh, sorry, was it? Look, as I'll try and do as much of it as I can in my head. But 250 over 3 minus 75 over 2 plus 10 minus 2 over 3 minus 3 over 2 minus 2. Somebody can put all that into the calculator, that's probably a bit quicker. Just let me know what it comes out as. So lads, this one here is 60, excuse me, and the original one was 96. So excuse me, I did get plus 36 after all. So the overall area is going to be 96 minus 60. Which is basically, yeah, if you did like that, 96 minus 60, and the area of the full thing is 36. Okay, so what we get is an open cylindrical tank of water has a hole near the bottom. The radius of the tank is 52. So the difference between this and a sphere question is, you know when a sphere gets smaller, it's not a snowball question. The radius keeps changing, but the radius is set in stone here. It can never change. Even at your very last bit of water, will just be down here. It still has a radius of 52, no matter what happens to it. So the radius is fixed, okay? So as such, is treated like a constant. Do you everybody get that? Radius can't change, okay? So the hole is a circle of radius 1. We're going to use that in part 4. The water level gradually drops as the water escapes through the hole. Over a 20-minute period, the height of the surface of the water is given by the formula h equals 10 minus t over 200 squared. This formula works for a 20 minutes time frame. Would you agree with that? Now, just a bit of interest. What type of function is this going to be? Is it going to be a plus t squared or a minus t squared when you multiply it out? It's a plus t squared, so you're basically discussing a u-shaped function, aren't you? So, and what they're doing is your water is decreasing over time, isn't it? So what you're doing is you're limiting the scope of your experiment to probably this side. See, it's a decreasing function. Your height is getting smaller over time. And then eventually it's going to go back up again, but that's not possible for this question. So any times that are over your 20-minute time span are not allowed. So all your answers, this is telling you, all your answers are 0 to 20. Okay? Now, they always did this. They did this in part 9 as well. It's just, can you use a calculator? Is the first 2 questions usually. Okay? So what they're saying is, what's the height of the surface at t equals 0? Fine. I'll get this formula and I'll just replace in t equals 0. And what I'm going to get there is 100 centimeters. Thank you very much, I'll have that. Okay. Next one is, after how many seconds will the height of the surface be 64? Now let me explain. There's two ways to go at this. Okay, your height formula is 10 minus t over 200 squared, and that is going to equal 64. Now there's two ways to come at this. I could square out the brackets, I could turn it into a quadratic equation, I could get rid of the, it's going to be 40,000 on the bottom. I have to multiply every fraction in there by 40,000 to get rid of it, and then I can do a minus b formula, I can solve it. Have a much quicker way, right? Yeah, now what I'm planning of here is, if we change this whole thing here to y squared equals 64, we can then say that y equals 8, or y equals minus 8. Having done that, what I can next say is that 10 minus t over 200 equals 8. 10 minus t over 200 equals minus 8. Upon doing that, what we can say next is that 2 equals t over 200. And what do we say t is then? T equals 400. 400 is? What? Seconds. Oh, that's good. So 400 seconds, okay, so 400 seconds is allowed, okay, and then the other one is cross multiply by, bring the 10 over the other side, we get minus 18 equals minus t over 200, just forget about the minuses, t equals 3,600. Now 3,600 is 60 minutes, and we know that's banned, so that doesn't count. T equals 400 seconds is your answer. Cool with that? Yes, Ken? Find the rate at which the volume of the water in the tank is decreasing at the instant when the height is 64 centimeters. Now, the height equals 64 centimeters brings us back to information from part B. Information from part B is when the height is 64. So we know that this happens after 400 seconds. So we automatically have a bit more information than we thought. We actually had, now in the event that you couldn't do part B for some reason, what would you do? Write down a bunch of gibberish and give yourself a time, and then use it in part C. Okay, because that means that you can still get marks. But if you don't get part B, but you might have an idea how to attempt C, just make up an answer for B and roll with it. Okay? So find the rate at which the volume of water, so what did I say? T is 400, yeah? Now, volume of a water tank is decreasing. Rate. Give me two letters for that. We were doing it yesterday. We were looking at dV dt, aren't we? Now, this is part C, isn't it? So we're on dV dt. Now, what we know is that the volume of your tank is pi r squared h. Is r a variable? So we just lob in your 52. It's set in stone, can't change. So what's 52 squared is 2,704 pi h. The only thing that changes is the h. Okay? So therefore, we're still looking for the dV dt. Okay, and what we're going to do with the dV dt is we're going to use dV dh and dh dt, I think. dh dt. Now, the hard part is, alright, you want dV dt, perfect. Now we're going to find dV dh quite easily. So you'd get most people will pick up a 10 marks for this, okay? So we're going to find dV dh by differentiating this. Anybody know the answer? 2704 pi. Just the h drops. In the same way that when you differentiate 5x you get 5. Okay? So, what we have is our 2704 pi, and dV dt is the purpose of the question. That's in the box. This means we must have a way to get this answer. There must be something in the question that tells us how to do that. Okay? Now, what we're going to do next is, I just want to get a bit more graph paper here, because this is annoying me. 1 second. There we go. Okay, now I'm happy. Now, what happens next is there's a formula for H, isn't there? The formula for H is 10 minus T over 200 squared. If I differentiate this, I find out what dH dt is, right? So, differentiate it. What type of rule is it? Chain rule. Now, let me explain the chain rule. The 2 goes to the front. What's in the chain remains unchanged. No pun intended. Okay? And then you differentiate what's in the chain. Okay? Yeah, just leaving it there. Yeah, take 1 away from the power. Okay? Now, what happens here is the 10 isn't differentiable. I have to differentiate minus t over 200. Same thing as minus 1 over 200 t. Same thing as any constant but one letter beside it. The letter just drops. In the same way that 5t is 5, in the same way minus 200t is minus 200. Okay? So what we're going to get is minus 1 over 200. Okay? Now, what happens next is, yes?
Wait, if the power was more than 2.
Now guys, what we're doing next is we're looking at the 2 and the 200. So it cancels to minus, it's here I'm putting it. So it's going to be minus 1 over 100, yeah? And then it's going to be 110 minus, oh dear. Now, what we have here, guys, is what I was saying was, is this writing for me? It is writing for me, great. Now, what we have here is our 10 minus t over 200 multiplied by what we said was minus 1 over 100 then, didn't we? Because we cancelled the 2. Now, the great thing about this is we know that t equals 400. So replacing 400, what did you say? It's minus 4, it's going to be 8 then. So it's going to be minus 8 because it's, 2 minus, it's 8, you're right. It's going to be 8 multiplied by minus 1 over 100. And when you multiply the two of them together, you're going to get minus 4 over 25. Just put it into the calculator and you get minus 4 over 25. Now all of a sudden we're in business with what we're doing with this part here, because we know every number on the right hand side, so we just got to multiply it out. So there's 2 possible answers for this. Now please remember, volume changing with time, what is that? cm cubes per second. No, it's cm cubed s to the minus 1 per second. S to minus 1 means per second. Okay? So what we're going to get here when we put this in is 2 different answers. The first answer will be minus 216.32 pi. Second answer being minus roughly 680. And I'm just going to put both units in, centimeters cubed per second and centimeters cubed per second. Happy enough with that? Now, part D. The rate at which the volume of water in the tank is decreasing is equal to the speed of the water coming out of the hole multiplied by the area of the hole. Find the speed at which the water is coming out of the hole at the instant when the hole is when the height of the hole is 64. Now, see the significance of the height of the hole equals 64. In parts B and C, we just accumulated a mammoth amount of information on that. we've accumulated the following information before we even begin. We already know that t is 400. We already know that the VDT is negative minus 216.32 pi. Is there anything else we got that I should know about? Sorry? dVdh, yeah, we had the VDH earlier, didn't we?
Yeah.
It's that there, isn't it?
Yeah.
So the VDH is, and we also did dH dt. I rubbed it out, but we had done it, and I will use it if I have to. Okay. So the VDH is 2704 pi, and just for argument's sake, I'll put down the VD. I'll just put down the V. I'll put down the VDT now. Where is the VDT? Oh, sorry, the HDT. Excuse me. The HDT was 2 multiplied by 10 minus t over 200, and then 1 minus 200 behind. Now, I haven't even read the question yet, guys. I'm just writing down everything I already have for 64, just so I know it's at hand if I need it. Okay. Now, what we're going to do next is not what I did there anyway. Let's undo that. There we go. Now, what we're looking at here is the rate at which the volume of the water in the tank decreases equal to the speed of the water coming out of the hole multiplied by the area of the hole. So let me explain what happens. When you have a cylinder and your cylinder loses a bit of volume, okay, so you have your cylinder here, and then when you lose a bit of volume, and then at the side of it, it's going to have a small gap. I'm going to make it a larger gap just for the sake of it, okay? Now, what happens is, it's the rate. So if you imagine that the water comes straight out, it's technically a cylinder of water, isn't it? Do you know when water flies out of a circular hole? If you pause it, if you freeze frame it over 1 second, and you really zoom in, like this is really zoomed in before gravity drags it down and bends it, okay? What I'm trying to say is that it's actually technically a cylinder of water. So there's a cylinder of water exiting every second. Okay, so if I lose this amount here in 1 second, see the way that's cone shaped, yeah? If I lose that much in 1 second, that means that these two areas are the same, because the cylinder represents how much water exits the large cylinder every second. Okay, so I just want to get that into your head starting off. Now, although this is decreasing, your volume is decreasing, right? Speed is technically positive, isn't it? So one of them's going to be negative while the other one is positive. Okay, now I'm going to get rid of that now and actually just go about doing this question now, okay? So once you get that into your head, we can begin. Now, I'm going to use U as the velocity. U equals velocity. Reason being, I'm already using V for volume. I'm in a test. I do not want a second V in my question because it will confuse me and I'll make a mistake. Okay, so U is the velocity, okay? You can always pick a different letter if that letter is already used. There's nothing wrong with that. Just spell it out for them, okay? So then what we're going to say is that U, where did we do that again? Oh, this is D. Okay, so what we're going to say that the VDT, the rate at which the volume is decreasing, is equal to the speed of the water coming out, so it's equal to minus AU. Everybody happy with that? Because it's the speed of the water coming out multiplied by the area of the hole. Okay. Step after that is we know that the area of the hole is pi r squared. At the very beginning of the question, it said that the radius is 1, so it's now minus pi u. The VDT equals minus pi u. Is that right? Now, what we have to do next is find out the. Oh, we know the VDT is. There it is there. There's our information coming in handy now. We have a direct substitution. And because of that being negative, the reason why I put a negative at the start was because, is that what you're going to ask me? The reason why I put a negative at the start is, remember, your volume is decreasing, which means it's automatically negative. Area has to be positive, and speed is also positive. So I needed a negative there to balance it out. You can leave the negative out and just keep track that it can be positive or negative, but I really wanted it there, okay? So what we're looking at next is that u equals, what was it, 216, and now it's a speed, isn't it? Meters per second, centimeters per second. So cms or cm s to the minus 1. Okay.
So
Yes.
the
In this question here, guys, you show that as time varies, the speed of the water coming out of the hole is a constant multiple of h. So what we learned in the last question was that dv dt was equal to minus pi times, what was it, a times u. Therefore its speed, and we found out that a was just pi, so it's minus pi u. That's all from the last question. Cross multiply down, so we're going to find out that u equals minus 1 over pi dv dt. I just brought the pi and the minus 1 down to the other side. Okay, upon completion of that, what you then realise is that, what do we realise next? The pi's will, dv dt, and this is going back to part C. The VDT is 2,704 pi multiplied by dHdt. Reason why we did that changeover is we're trying to relate the information back to h, not back to v. Okay, so I need to bring the h's into play. Okay, so what's going to happen then is u equals minus 1 over pi multiplied by 2,704 pi dHdt. Okay, and then that means that u is going to be equal to minus, the pi's are going to cancel, right? And then it's minus plus 2,704. We also know what dHdt is from earlier as well, don't we? We differentiate dHdt in part B and C. So we know what dHdt is. So it's going to be minus 2,704, which is from the 2 pi's cancelling. Now I'm going to look for the dHdt I've already done previously to this. The dHdt that I already did previously to this, it's down there actually, it's right underneath. Do you see it? So what I'm going to do is, I'll need a bit more space, so it's going to be u equals minus 2,704 multiplied by 2 multiplied by 10 minus t over 200 multiplied by minus 1 over 200. The 2 cancels with the 200 to come at 100. Divide minus 2,704 divided by 100, and you're going to get dHdt is 27.04 multiplied by, what the hell is that, 10 minus t over 200. Okay, that's your right there, okay? Now, does it say anything about the, this part I never would have got in a million years, right? This part here is, it wants me to show that it's related to root h. When you go to the very beginning of your question, it says that h equals 10 minus 2t over 200 squared. You'll notice that this thing here is the same as this one here. Square root both sides, that's a root h, and that's t to the power 1. dHdt therefore equals 27.04 root h. Okay, so last question is, the speed of centimeters per second if the water coming out of the hole is like this number here. So what you do is you say that phi equals c times root 1962 times root h. I'm just finishing off a video from the last class so I can upload it for them. Equals 27.04 root h. Just the answer we got from the last question. Root h is cancelled, and then you're going to find out that your c value multiplied by root 1962 equals 27.04. C equals 27.04 divided by root 1962. Divide that by root 1962 and you get 0.6104. And